So in this problem, what we're going to do is we're going to find the inverse of a matrix, okay, using elementary row transformation. So the matrix which is being given here is this matrix over here. The matrix being 2 and 1 in the first row and 1 and 1 in the second row. So let's consider this matrix as matrix A. So we know that any matrix into an identity matrix is a matrix itself. So we're going to write that down. So let's just substitute the values of A on the LHS and I on the RHS. So we know that if we're going to make the what we're going to do now is we're going to make the LHS, which is the matrix A, into an identity matrix. So when we are making that into an identity matrix, the RHS, which is the where we have the identity matrix, is automatically going to become into your inverse matrix. Okay, so we're gonna just apply a few rules over here. This is a very important 4-mark question, so know that you know this properly. So what we're gonna do now is we're gonna have R1 and we're going to make the first element into 1, okay, because an identity matrix consists of 1, 0 and 0, 1. So what we have to do is first we're going to try and get a 1 in the first position. So to get that, we're going to do R1 is equal to R1 minus R2. So once you've done that, you're going to get 1, 0 and 1, 1 on the LHS. So remember that you always have to apply the operations on both the LHS and the RHS. Okay, so now that we've done that, we have to get a 0 in your LHS, in your third element. Okay, so to do that, what we're going to do is we're just going to take the second row and minus to the first row. So once you've done that, you're going to get your identity matrix over here, which is going to be 1, 0, 0, 1. And since you got the identity element on the identity matrix on the LHS, so you're obviously going to have an inverse matrix on the RHS. So the matrix on the RHS is going to be your inverse matrix. So that's going to be your answer.